Hi, let's get started with Lesson 3, Hadoop and Oracle Big Data SQL Architectures. In this lesson, you will learn the following. Review the Apache Hadoop and Oracle Big Data SQL architectures, create Oracle external tables over data in HDFS and Hive, and understand the two components involved in deploying Oracle Big Data SQL. At a high level, Hadoop architecture has the following layers. Distributed storage using HDFS or NoSQL databases, resource management using Yarn and C groups, distributed processing using MapReduce, Hive, Spark, and other processing engines, and metadata store using Apache Hive. Data is stored in files and is organized into folders. Data files can be of any type, and the files are replicated 3 times across the cluster. Schema on read means that the tool reading the data interprets the data as it sees appropriate. Hive provides some level of organization to the stored data. Folders have meanings. Information about the stored data is captured in the Hive metastore. HDFS folders become databases, tables, and partitions. In this example, the Hive warehouse has a folder named Hive Warehouse. The database name is data.db. There are 2 tables, HR and website. There is also few partitions, month equal 2016-01 and month equal 2016-02. Basically, Hive is creating a metadata layer on top of the data that lives in Hadoop. A table includes metadata for parsing data using Java classes. The input format enables you to specify the Java class that will read data from the Hive table. The record reader enables you to specify the Java class that will write data to the Hive table. And seriad or serializer deserializer is the Java technology that Hive uses to process records and map them to column data types in Hive tables. Earlier, we said data is stored in files and is organized into folders and that the files can be of any type. Here's an example where we have 2 kinds of files. Salaries.csv, which is a comma-separated values file, and it contains salaries data. And click3.json, which is a JSON file, and it contains the movieplex click data. Hive has a framework that enables you to query any type of data. As long as you have the programs or Java classes that can read and interpret the data, you can process it with SQL. Hive also supports various SQL execution types. Hive can use either MapReduce or Spark frameworks. In the slide example, Hive is reading data from HDFS. A Java deserializer formats the data into a record that maps to a table column data type. For example, if you have 1 terabyte of data, HDFS will split the data into 256 megabytes block size or input splits. This enables parallel processing of the input splits in the cluster. Next, you want to break each of the blocks into records. The record reader breaks down each input split into records. Next, now that you have the records, how do you get the fields or attributes? You'll look at a code example that shows how to do that in few slides. After attributes or columns of the tables are identified, you can use the SQL query in the example to access the data. Hive provides a single way of defining the metadata in the Hive metastore, and then different processing engines such as MapReduce and Spark and SmartScan can leverage the metadata to process the data. If the files are broken into subdirectories, you can also do partition pruning. In this example, because your query is only looking for data in January 2016, you only need to look at one partition that contains that data. There are 2 parts to Oracle Big Data SQL. The Enhanced Oracle Database 12c external tables, and the Oracle Big Data SQL Server cells on the Oracle Big Data Appliance or do-it-yourself Hadoop clusters. On the Hadoop cluster, Big Data SQL Server cells apply SmartScan over the data stored in HDFS data nodes in order to achieve fast performance. In a true Oracle Big Data environment, there are two installation tasks. First, install Oracle Big Data SQL on the Hadoop cluster. This step sets up a Big Data SQL Server cells on each data node in the Hadoop cluster. This enables SmartScan on local data. The second step, for Oracle Database 12c, run the Big Data SQL installation script on each Oracle database node. This step sets up connectivity from the Oracle database to the Big Data SQL Server cells on the Hadoop cluster. It also includes installing Hadoop client, configuration directories and files, Big Data SQL agent, Oracle directory objects, and more. An external table is an Oracle database object that identifies and describes the location of data outside of a database. You can query any external table using the same SQL syntax that you use for any other database table. An external table accesses data and external sources as if this data is in a table in the database. The data can be in any format for which an access driver is provided. You can use SQL, PL/SQL, and Java to query external tables. External tables are useful when an Oracle database application must access non-relational data. As you saw on the demo in Lesson 2, Oracle Big Data SQL enables support for HDFS data by providing metadata packages that are used by Oracle external tables. These features enable Big Data SQL to access data in a Hadoop cluster and remote Hive databases and tables. Oracle Database 12.102 and higher supports two new access drivers for Oracle Big Data SQL. The Oracle Hive Access Driver enables you to create Oracle external tables over Apache Hive data sources. Use this access driver when you already have Hive tables defined in your HDFS data sources. The Oracle HDFS Access Driver enables you to create Oracle external tables directly over files stored in HDFS. This access driver uses Hive syntax to describe a data source. You do not need to create a Hive table manually as a separate step. When you create the external table that uses the Oracle HDFS or Oracle Hive access drivers, you can use the access parameters clause in the create table organization external statement to override the default values. For example, if the Hive table name in the Hive metastore does not match the name of the external table, you can use the COM Oracle Big Data Table Name access parameter to specify the Hive table name. We'll look at some code examples in this lesson. There are tools available to automatically generate external tables, and we'll talk about those tools later in this lesson. Oracle Big Data SQL provides additional enhancements on external tables, making them work more like internal tables. These enhancements include performance by enabling parallelism and storage handler support for NoSQL stores, including HBase and Oracle NoSQL. The MoviePlex application streams data into the user Oracle MovieWork AppLog JSON HDFS directory. The first code example shows the contents of the AppLog JSON directory. This directory contains a single file named movieapplog.json.log. The second code example uses the tail command to show the last 10 lines of the movieapplog.json.log file. Notice that the file contains every click that has taken place on the website. The JSON log captures the following information about each interaction: customer ID, movie ID, genre ID, time, recommended, and activity. We will use this file in the examples on the next few pages. To use the Oracle HDFS Access Driver to access HDFS data, you must create the external table for HDFS files manually. and provide all the information that the access driver needs to locate the data and parse the records and fields. In this example, we're creating an external table named MovieLog to access the data in all files stored in the user Oracle MovieWork AppLog.json HDFS directory by using the Oracle HDFS access driver. This HDFS directory contains only one file. Because no access parameters are set in the statement, the Oracle HDFS access driver uses its default settings to do the following. The Oracle HDFS access driver indicates that the data is stored in HDFS. The location clause contains a comma-separated list of the HDFS file locations that contains the source data for the external table. The default directory clause identifies an Oracle database directory object, which identifies an operating system directory with files that the external table reads and writes. The reject limit applies to each parallel query slave that is executing the query. Next, let's query the HDFS data in the newly created MovieLog table. Note that the output looks similar to the previous tail command output. A record is returned for each JSON document. We are restricting the returned rows to only 19 using the condition in the where clause. You can override the default behavior of the Oracle HDFS access driver by setting properties in the access parameters clause of the external table definition. The access parameters clause provides information that the access driver needs to load the data correctly into the external table. The example specifies two properties within the access parameters clause. The COM Oracle Big Data Overflow parameter describes how to handle string data that is too long for the columns in the external table. In this example, values longer than 40 characters for the click column are truncated. Clearly, this is going to be a problem. The length of a JSON document exceeds that size. There are several ways to handle this situation, including Option 1, generate an error and then either reject a record, sets its values to null, or replace it with an alternate value. Option 2, simply truncate the data as we're doing here. This truncate action applies to all columns in the table, but you can also specify the individual columns to truncate. This table has only one column. The second property that we're specifying within the access parameter is the big data line. This cluster will be used instead of the default, which in this case happens to be the same. As a result of the click column being varchar 240 and using the truncate action, each JSON document is truncated based on that size of the Oracle table column. In practice, truncating a JSON document is not very useful, but this example illustrates the point. Oracle Database 12c, 12.102 and higher includes native JSON support. This allows queries to easily extract attribute data from JSON documents. The column specification in the select list is a full path to the JSON attribute. The specification starts with the table alias M, which is required, followed by the external stable column name, click, and then a case-sensitive JSON path such as genre ID. In the query example, we're only accessing the highlighted cust ID, movie ID, genre ID, and time JSON file attributes. This slide shows a simple example of how to join RDBMS and Hadoop data. One of the key strengths of Oracle Big Data SQL is the ability to answer questions that combine data from the Oracle database and Hadoop. The example combines the data from the click table in HDFS with data stored from the movie dimension table in the Oracle database. The partial output enables us to see how a given customer's movie's ratings on the website compared to the movie's gross revenues. The slide example creates an external table named movie app log JSON to access Hive data. Because no access parameters are set in the statement, the Oracle Hive Access driver uses the default settings to do the following: connects to the default Hadoop cluster, uses a Hive table named movie app log JSON. An error results if the Hive table does not have fields named cust ID, movie ID, and so on. It also sets the value of a field to null if there is a conversion error, such as a recommend value longer than 4 bytes. The Oracle Hive Access drivers invokes Oracle Big Data SQL a query compilation time to retrieve the metadata details from the Hive metastore. By default, it will query the metastore for a table name that matches the name of the external table that we're creating, movie app log JSON. Next, let's query the newly created external table. Note the following. As mentioned earlier, at query compilation time, Oracle Big Data SQL queries the Hive metastore for all information required to select data. This metadata includes the location of the data and the classes required to process the data, such as storage handlers, input formats, and SQLIDs. In this example, Oracle Big Data SQL scanned the files found in the user Oracle moviework applog.json directory and then used the Hive SQLID to parse each JSON document. In a true Oracle Big Data Appliance environment, the input splits would be processed in parallel across the nodes of the cluster by the Big Data SQL Server cells. The data would then be filtered locally using Smart Scan, and only the filtered results, rows and columns, would be returned to the Oracle database. Earlier, you learned how to override the default behavior of Oracle HDFS Access Driver. You can also override the default behavior of the Oracle Hive Access Driver by setting properties in the Access Parameters clause of the external table definition. The example expands upon the Create Table Organization external statement shown in the previous slide. In this example, the Oracle external table name, mylogdata, does not match the Hive table name. Therefore, an access parameters was specified that references the movie app log avro Hive table in the default Hive database. Use the Oracle Hive Access driver when possible. The shape of the table is fixed. You define columns in Oracle external tables. Therefore, if you add columns to the table in Hive, then the external table must be updated with the new columns. However, changes to partitioning, file types, and so on can change, and there are no required changes to the Oracle external table. We will talk about the performance features in Lesson 4, Oracle Big Data SQL Performance Features. To enable Oracle Big Data SQL to query Hive data, you must first define an Oracle external table for your Hive data. There are a number of tools available to help you create the Oracle external table definition. You can use the DBMS Hadoop PL/SQL package that contains the create ext DDL for Hive procedure. This procedure generates the data definition language, or DDL, to create an Oracle external table for a given Hive table. You can optionally edit the text of the generated DDL before execution in order to customize the external table properties. You can also use the Big Data SQL wizard in Oracle SQL Developer. The most recent versions of the free Oracle SQL Developer tool includes a Big Data SQL wizard that guides you easily through the process of creating Oracle external table definitions. You can also use the free Oracle SQL Developer Data Modeler to connect to a Hive metastore and generate an external table. You can select and import one or multiple Hive tables, modify table properties as needed, and then generate a DDL that you can copy into a SQL worksheet. Next, you run the SQL worksheet to create the external table. Although the data modeler is a more complex tool to use than other options, its advantage is that you can use it to work on multiple Hive tables. This is the diagram that we viewed earlier in this lesson. There are many query execution engines that use the Hive metastore while bypassing the Hive execution engine. Oracle Big Data SQL is an example of such an engine. This means that the same metadata can be shared across multiple products such as Hive, Oracle Big Data SQL, Impala, Pig, Spark SQL, and so on. This diagram shows how Big Data SQL sits on top of the Hive data. You will learn about the Oracle Big Data SQL performance features in the Oracle Big Data Performance Features lesson. This slide lists some of the useful Big Data SQL resources. In this lesson, you'll learn about the Apache Hadoop and Oracle Big Data SQL architectures, how to create Oracle external tables over data in HDFS and Hive, and reviewed at a high level the two components involved in deploying Oracle Big Data SQL. Thanks for watching.